Hi guys, today we are going to talk about the atomic structure. This is Divya Pradhan again. Alright, so what is an atom? Atom for now we'll understand as the smallest building block of matter. As you'll go to higher classes, you'll understand that this is no longer true, but still for now, atom is the smallest building block of matter. And this atom is composed of three subatomic particles: proton, neutron, electron. All right. So let's talk about little bit more about the proton. Proton is written as this P plus. Okay. It has a mass of 1 and a charge of +1. An electron is written like this. It has no mass. It has a charge of -1. A neutron written like this has a mass of 1, but it has no charge. So three subatomic particles: proton, electron, and neutron. All right. So let's look at a periodic table. What's a periodic table? Scientists arranged the atoms of the elements in a table format, so that, and with an increasing atomic number. I'll explain all these terms, okay? And then they arranged it in rows and in tables. What they noticed was that elements with similar chemical composition reoccurred. So here, all the elements in this column had very similar chemical properties. All the elements in this column had very similar properties. That's the periodic table. Well, a periodic table, you will see that every element is denoted by a chemical symbol. So we don't write HYDROGEN, we write just H. Every element has an atomic mass. Atomic mass, for now, atomic mass and atomic weight is different, okay? So atomic mass, know that it is the number of what? It is number of protons and the number of neutrons. So for hydrogen, what we are saying is that it has 1 proton, but it has no neutrons. Atomic number is nothing but the number of protons. Always remember that in an atom, the number of protons and the number of electrons is same. Okay? An atom has no charge. If there's 1 proton, then there's 1 electron. If there are 2 protons, then there are 2 electrons. In an atom, remember I said atom. So the atomic number, which actually denotes the number of protons, is also the number of electrons in an atom. So what are we saying? Hydrogen has 1 proton and it has therefore 1 electron. It has no neutrons. All right. So let's now how do we draw this electron? This atom. To draw an atom, we use the Bohr's model. Nobody can show you an atom, but what we can explain to you is via a model. We can explain where the subatomic particles are found. So for an hydrogen or for any other atom, there's a nucleus. Nucleus is in the center. It has the protons and the neutrons. Remember, a hydrogen has only 1 proton. It has no neutrons. And then around the nucleus are the shells, okay? And the shells will house the electrons. Now, this one, if you remember hydrogen, what did we write? Hydrogen has 1 proton and it has 1 electron. So therefore, what happens is the nucleus has 1 proton and therefore it has 1 electron, all right, in the first shell. Let's look at the helium. Helium has the atomic mass of 4. That means it has this is the number of protons plus what? Neutrons. Now, what is 2? 2 is the number of protons. How many protons it has? It has 2 protons. Because it has 2 protons, therefore it also has 2 electrons, because in an atom, number of protons and number of electrons is same. All right. So what we are saying is atomic mass is 4. 4 is nothing but protons plus neutrons. Of 4, 2 are protons. Therefore, how many neutrons? Well, of course, there are 2 neutrons. How will we draw the Bohr's model of helium? So here is the Bohr's model. There are 2 protons and 2 neutrons in the nucleus. Surrounding the nucleus is the first shell. Now, the first shell can house only 2 electrons. Like, for example, in a cinema hall. In a cinema hall, each row can accommodate certain number of seats, just like that, the first row can have 2 electrons. The second row, 8 electrons. Third row, 8 electrons. Fourth row, 8 electrons. Fifth row, 8 electrons. However, helium has only 2 electrons, so all the other shells can remain empty. They don't exist, okay? Let's look at lithium. Lithium, the atomic mass is 6.9, which is 7, all right? So here the atomic mass, remember, is number of protons plus number of neutrons, we are saying is 7. But we're also saying that the atomic number, which is number of protons, is how many? 3. Because it has 3 protons, it also has 3 electrons, all right? Because in an atom, proton and electrons are same. So therefore, how many neutrons? Well, number of neutrons is what? Of course, 4, because protons and neutrons is 7 as per our as per our periodic table, and therefore what happens is the number of neutrons is 4. So you just subtract from here, you get 4. Okay. So here's the lithium model. There are 3 protons, 4 neutrons in the nucleus. The first shell can house only 2 electrons. Remember, we have to accommodate 3 electrons. First shell 2, so the second shell will get 1 electron. So it has how many electrons in the outermost orbit? It has 1 electron. This is called valence electron, okay? Valence electrons. So this determines the reactivity. What did we say? We said that a shell except the first can house how many? It can house 8 electrons. This is the octet rule, or the rule of 8. All right. So let's say, for example, lithium itself. It has 1 electron. To be stable, it needs how many? It needs 8. So either it can take in 7 or give up 1. Right? And which one is easier? Take in 7 or give up 1? Of course, the easiest method will be give up 1. So what it does is it will remove 1. Because it removes 1, remember at first we started with how many protons? We started with 3 protons. How many electrons did we start out with? We said 3. When we arranged the electrons, first shell had 2, second shell had 1. Keeping 1 was not stable. It was not a good idea. So now what it does is it gives up 1 electron. Because it gives up 1 electron, therefore what happens is now it becomes how many? It becomes how many electrons? 2. So now lithium, because it gives up 1 electron, who's winning? It has 3 protons, but now it has how many electrons? 2. So therefore it will get a charge of +1. We don't write +1, we don't even write 1, we just write lithium. It has a valency, understanding. We understand that it has a valency of 1. All right. So again, same point repeated. Electrons in the outermost shell are called valence electrons, and this will the atoms with fewer than maximum number of electrons in the outermost shell will determine how reactive it is. So now there are some elements, for example, xenon, radon. They have valence electrons like, okay, let's see, xenon. So here what happens is it has 10. That means the atomic number is 10. Number of electrons is how many? 10. Oops, excuse me. It has 10. So how will I draw this? Well, I will draw the nucleus and I'll draw the shells. The first shell will have how many? It will have 2 electrons. The second shell will have how many? It has 8 electrons. I'm drawing the 8 electrons. It is already stable. We already are number 8. Well, is it reactive? No. It is already stable. It doesn't need to react. All right. But on the other hand, if I have an atom, say what happens is with 2, and it has, say for example, 7. 1, 2, 3, 4, 5, 6, 7. Is it stable? Nah. Because to be stable, how many electrons should be there? 8. So either it can give up 7 or bring in 1. Well, which one is easier? Bring in 1, of course. So this idea, let's scrap it away. And of course, 1 electron needs to come. As soon as 1 electron will come here, remember, in this, what did we start out with? Protons, how many did we have? Well, we had 9 protons. And how many electrons did we have? 9. But was that stable? No. We brought in 1 extra electron. So now the total number of electrons is 10. So now this element, whatever this element, let's name this element X or Y or Z, whatever, will now have a charge of what? Minus what? 1. That's how the elements get valency. And now you understand that there are these noble gases, like for example the xenon, they are noble gases. They are non-reactive, and the reason being they have 8 electrons in the outermost shell. So with this, hopefully now you understand about the atom, atomic structure, valence electrons, and Bohr's model. So we'll talk about it more in the other videos. Be sure to read the textbook, and please talk to me, come and see me if you still need more help. Thank you. Bye.